Hello, ladies and gentlemen. How's everybody doing? Today, we are going to talk about chemical reactions. And when it says, like, this statement here seems really like, oh, life depends on chemical reactions, like very cerebral. But ultimately, what chemical reactions are bonds breaking and bonds forming. Okay, so one substance um, changes into another, or two substances change into one other. Um, and we have to start by identifying the two parts of a chemical reaction. So in my example here, and I'm just going to bump around where I'm located so we can see a little bit better. A chemical reaction always has two parts. The part on the left, and then the part on the right of this arrow. Everybody see the arrow. So in our chemical reaction, the items to the left are called the reactants. The areas to the right are called the products. So reactants start a chemical reaction. Products are what results. Okay. Now it's interesting because every reaction takes a certain amount of energy. That energy has to be added. And when that energy is used to like break the bond, there's kind of you can measure it and we can represent it, which is kind of neat. The breaking of the bonds themselves leads to a release. And then it depends on the type of reaction, depending on how much energy is released, or actually in some cases, more energy can be stored, or more energy can be released. But some reactions, many of them, result in what's called equilibrium. So reactants and products form at the same rate. So we have an arrow actually going in both directions. And we say that that is what is called chemical equilibrium. When we are looking at a reaction, a couple of things have to happen in terms of graphs. I know, wait a minute, biology class, graphs? Yes. So first things first, this is our graph of a reaction as if it's proceeding. Like this reaction is happening. So here are our reactants. This is energy. This is the reaction, and it's kind of going forward. This value here is activation energy. It's what gets the reaction going. It starts the chemical reaction. So this example here is a person pushing a ball up a hill. And then once it gets to the top, the person doesn't need to push it anymore. It just rolls down the hill. So with that, there are two types of chemical reactions. Here we have exothermic reactions, and pay really close attention to the graph. Sorry, I kind of came a little close there. So in an exothermic reaction, we have our reactants, we have our activation energy. We're going up, 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 up. When we get to the top, we roll down the hill. Again, this is our chemical reaction. It's going, it's going, it's going. Here are our products. And notice, if we carry this line over, all the way over to the products, energy is released. The amount of energy in the products is less than where we started in the reactants. So this type of reaction, exothermic reactions, they release energy. Okay. I think like exoskeleton, like insects have an exoskeleton. They have a skeleton on the outside. Out, release. I don't know. I'm trying to help you guys make a little connection there. The other type of reaction is an endothermic reaction. So here we have our reactants, We're going up, 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 up. We're taking our ball, we're pushing it up the hill. We let the ball roll down, 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 down. Here are our products. But here, if we continue the line across, all the way across from the reactants, the energy in the products is higher, which means energy is stored or absorbed in the reaction. So endo, think inside, endo, in, as opposed to exo, outside. So here, in an endothermic reaction, reactants, products, looking at the progress of the reaction, the amount of energy at the end is higher than it started, which means the energy is absorbed. And that is our basic lesson on chemical reactions. Two types are exothermic and endothermic reactions. And in the next video, we're going to look at the details of the graph more closely.